take a look here at a few minutes at Objective 2.3, which is troubleshoot interface and cable issues, collisions, errors, duplex, and speed. Try to demonstrate some of that as we go through, but interface and cable issues. The biggest cable issue that we had where I've worked have typically been physical issues. People trip over the cable, unplug the cable, the tab fails and the cable backs out, lots of humidity, you get a little bit of corrosion on the cable, and things don't work exactly as we expect them to. Little chart here, cable errors, and this says check the cable in both sides of the connection. If the link light for the port does not come on, what's the issue? No cable connected, should be easy to see. The wrong port, we think we're in one port and we're actually in another port. When we talk about VLANs, this could become very, very significant. The device has no power, it's been turned off. We actually had that happen one time with an instructor who was in a class doing something, and I don't know what it was, but he was doing a night class, didn't ask anybody about what was going on. The next morning we came in and said, nothing worked in that room last night. Nobody could connect to anybody else, couldn't connect to the computers within the room, couldn't connect out. The device was kind of hidden. I finally went directly and looked at the device and found out that it was turned off. The central device, in this case it was a hub, but same. Wrong cable type, the cable selection, and this says the switch guide, and we've talked about that. Like to like is a crossover cable. And we'll go to the console ports, a rollover cable. And a rollover cable is 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 6, 5, 4, 3, 2, 1. You just actually roll them over. If you're making them, you make one with the tab up and one with the tab down, using the standard cable definitions. Bad cable, swap the suspect with a known good cable. That's the easiest way to do these things, to find out. And if you have machines that are next to each other and we don't have port security enabled, we're going to do port security in a couple of objectives past this, then you can just swap side by side machines and see if the other one comes up a known good cable. Loose connections, sometimes the cable appears to be seated and the jack is not. Unplug it and reseat it. A couple of things I think can happen here. One is we get a little bit of corrosion. The other is the tab breaks on it and it does back out. So be sure that it is seated well, or somebody unplugged it and didn't plug it back in right. Patch panels, faulty patch panel connections could be the issue with these things. And then media converters, faulty media converters, fiber to copper. Bypass the converter if you can do that to rule these things out. And then down here, bad or wrong gigabit Ethernet converter, bad port or module or interface, or module not enabled. The module is in a shutdown mode where we give the command to shut it down. So, or the module is not enabled, the port's not enabled. Cable distances, and I think that I've talked about this a little bit, but you will notice in here that we have 100 meters showing up in a lot of locations. And this is 10 Cat 3. Old category 3 is going to be 10 megabits per second, full and half duplex, copper, 100 meters. Multimode fiber, we got 2 kilometers in here. Cat 5, Cat 5e, full and half duplex, copper, 100 meters. Cat 6, copper, 100 meters. Multimode fiber, half or full duplex, depending on which we are, half duplex, 400 meters, full duplex, 2 kilometers. And the differences between the half and the full duplex is because that we can get collisions in a half duplex situation. 100 meg, single mode fiber, 1300, 400 meters, and then full duplex, we can get 10 kilometers out of it. The single mode fiber is probably going to have a laser to generate the light signal instead of an LED, which is going to be used in the multi-mode fiber. So collisions can be the bane of our existence, can be a real issue for us. But a couple of things, they're not always abnormal. We go over here, half duplex and a half duplex operations are normal and should not worry about them as long as you can tolerate the performance when the half duplex mode is used. Tolerate the performance. We did an inadvertent experiment one time. We had a hub and a switch in a room. And some of the students were connected to the switch and some were connected to the hub. We were downloading a document. The switch got it. The people on the switch got it almost immediately. Not real fast still at this point in time, so maybe a minute. These guys over here, it's going to take 15 minutes to download it. So we talk about the performance hit. There definitely is a performance hit with hubs. Should never see collisions in a properly designed and configured network that uses full duplex. So we should never see them in a full duplex communication. That you use full duplex unless you have older legacy equipment that requires half duplex. So we should always be in a full duplex. And Cisco stuff is configured for auto configuration. In order to make these mismatches that we're going to talk about in a minute, to get the half duplex, we've got to go in and actually give a command to put it in half duplex mode. Late collisions that occurs after 512 bits of the frame, the preamble, have been transmitted. Excessive cable lengths are the most common cause of late collisions. And then another common cause is a duplex misconfiguration. And I've got some examples. My duplex misconfiguration didn't do this because it is in Packet Tracer and it's in a simulator. So simulators don't always work the way that we think they're going to. Duplex, for example, have one end of the connections configured for full and the other for half. We see late collisions on the interface that's configured for half duplex. Must configure the same duplex setting at both ends. And again, the way around that is just go in and configure them for auto, and that is the default in the Cisco devices. Speed duplex issues. Two different results due to the mismatch in the speed and duplex respectively. Speed mismatch, the lane won't come up. It's going to be down. What we're going to get, and we'll show some stuff here, we should get an up down. And when we do the show and we talk about up down, we're talking about layer 1 connectivity and layer 2 connectivity. Is it physically connected? It's up. Is the protocol working? No, the protocol being Ethernet is not working, so it's going to be down, and that's going to put it down. Duplex mismatch, going to be performance issues. You can see runts and other packet errors on the interface, and a run is something that's smaller than the specified 64 bytes. When we do, we'll see the collisions if both sides are configured for half duplex, and it's normal to see collisions then when we have a half duplex situation. To troubleshoot if both the devices are Cisco, put them in speed auto and duplex auto and see if that fixes the issue. Years ago, Cisco did have some kind of issues with auto negotiation, but I don't think there have been any for a number of years. These are some show commands that you can use to verify the switch configuration. So to display the interface status, show interfaces and then whatever the interface ID is. Display the startup configuration, show startup config when we make modifications to the device. We're going to copy the running configuration, which is going to be in memory, to the startup configuration, which is going to be stored in a flash RAM, so that we don't have to redo everything every time we turn the device off. Show flash is going to be in memory, and then show version is the version history, IP, and show MAC address table. And we've talked about the MAC address table, and we've actually looked at the MAC address table to see some of what's going on with the devices. Interface issues, we talked about mentioned runt frames shorter than the 64 byte minimum length are runts. Malfunctioning NICs are the usual cause of excessive runt frames. Giants are ones that are longer than the allowed length, cause the same issues as those that cause runts. CRC, cyclical redundancy check errors, usually indicate a media or a cable error. And common causes include electrical interference, loose or damaged cable. Electrical interference, fluorescent lights are the best one if we put copper in a power plant that's generating electricity, has lots of EMI. We can get the loose connections, damaged connections, incorrect cabling type. If you see these, too much noise on the link, you should inspect the cable for damage. You should also search to eliminate the noise sources if we can do that. And here's a little troubleshooting flow chart. Perform the show interface. Is the interface up? No. Verify the cables. Check the cables and the connectors for damage. Verify speed is properly set at both ends. Speed and duplex is properly set. If it is up, are there indications of EMI or noise? If it's yes, then we're going to remove the source. Verify the duplex setting is properly set at both ends, and this is if the duplex, yeah, they should be up with duplex, but we're having issues. Is duplex properly set? If it's down and we have a speed issue, mismatched speed, they're going to both ends be done. Is the problem solved? Yes, we're done. If not, then we're going to document the work and escalate the issue. What I wanted to do here is I've created a couple of configurations in Packet Tracer, and then the cable mismatch. We have this thing auto MDI and MDIX, which is an automatic when we automatically select the correct cable, much like our home routers do, because you can plug in a cable and it'll automatically say, oop, I need a straight through, oop, I need a crossover, and configure the port properly for that. If we don't have the auto MDIX, then we have an issue, and in this case we're using a straight through, and in Packet Tracer the solid are straight throughs and the dashed ones are going to be crossovers. So we're using a straight through like to like with a straight through, then we have an issue. The correct cable for like to like is going to be a crossover. And this one in the auto MDIX, it doesn't matter. A hub probably not going to detect that, and this one did not. The duplex mismatch here, we should have errors, but this in the simulator shows it as down, and then in the speed mismatch is the one where we're going to be down. And then talked about using the commands, and let's look at some of that. Let's look at the speed mismatch here. If I go in here, and again, hopefully you can see these things. Actually, yeah, let's just go ahead and do this. What we're going to do, we're going to go to enable mode, and then we're going to show interface as fast Ethernet 0/1, I think is the one that I used here. And then if we go up here, fast Ethernet is down, line protocol is down, disabled. Down encapsulation, keep alive, full duplex, which is what we would expect in a switch, 10 megabits per second. We're probably going to expect 100 meg in this thing. So we will go to the other end of it and do the same thing. Enable show interfaces FAST01 and make it big enough to see. We go down here. Bandwidth is 1,000 kilobytes, full duplex 100 meg. It is actually set that way. The other thing we could show, and I haven't saved this yet, but we'll show the running configuration. And when I go to here, I go speed 100. I have set it explicitly to 100. The other thing that it said that we could do is speed auto and then change to up. When we do that, we're going to now, since the other end is 10, we would have negotiated a 10 megabit connection, or we should have. Let's see here, a 10 meg, but since we have a speed match, and this is a thing called spanning tree, when you go into amber, it's negotiating to see or checking to see if there are any physical loops on this thing. It's back up now, so we are okay. Over here, the duplex mismatch, we should actually just get runts or other types of errors with the duplex mismatches. So kind of a visual on what may or may not happen when you have speed and duplex mismatches in the devices. So what we looked at, we talked about cable errors. Do we didn't get anything? Is it plugged in? Is it seated properly? Do we have an adapter issue? Those sorts of things. We looked at cable lengths. Cable that's too long can cause collisions because when we look at a signal, it has time and time has distance. It takes the signal so long to go across a cable. The cable's copper, generally speaking, as you saw, is going to be 100 meters. Anything longer than that, we can get late collisions. And we talked about collisions, duplex mismatch, those sorts of things. And then there were a number of verify commands where we can show different elements of what's going on the device itself. And then briefly, interface issues, what can cause us to get runts and giants, and then the flow chart for error testing. So that should take care of overview, a look at Objective 2.3, the troubleshoot interface and cable issues.